continuing on, we have this idea in 9.3 about the very tight relationship between an array and a pointer. You'll remember not 2 weeks ago here when we were still working with the refresher portion of this course, that when we were looking at the idea of an array and actually passing an array as, to another function as an argument, when we are passing those over, we are not in fact passing the array. We are passing a reference to the array over. Now, again, let's think about the size of an array as the primary reason that we're not actually passing over the array. We have been traditionally working with 5 and 10 and 20. And, for the homework the other week, I gave you 1,000 and 10,000 values in there. And think about how fast those actually completed when you were running them inside of your code. It took, moments. The 10,000 names one, I will tell you, probably ran for a couple of seconds, didn't it? So you hit run on that, and then nothing happened. That's exactly what was supposed to happen. Nothing, because it was churning away in the background. But remember, when we were passing over the array, we also passed over the size of the array, from wherever the calling argument was to the called function, rather. Why did we pass over the size of the array? Well, because C++ can do the lifting for you as long as you help it out. We passed over the reference, the address to where that array begins. Now, because C++ knows that the array has a size, and because C++ knows that the array has a type, it can work backwards and figure out, okay, if we start at this address, what's the next address where the next piece of data is going to begin? That's why we use the size parameter as a counter, right? So when we passed it over, we knew that, look, as long as you know where it starts and how many there are, you're not going to continue on past the end of the bounds of the array. Now, it's important to remember here, just one more time, that C++ does not do boundary checking here. So you that's what I'm trying to put the emphasis on here. You can code your product in such a way that you can continue on past the end, past the boundary of your array. And remember, it's not terminal. C++ will continue, but those values, those references, everything that you have done there is completely and totally unhandled. It's unrecoverable. There is no way to get those values back. Now, here we can see, again, this is program 9-5. This is on page 513. We have I'm trying to get this. I'm not implicating any of you specifically, although I know I did actually see this as a question 3 times over the course of this previous session. Here we've got the first element of our array is 10. Why is that? Because it's the 0th element in our array. We have here our short numbers array, and the first value in there is 10. So what we're really looking at, and you can see that here, and again, this is 513, is the array elements are stored starting at whatever the memory location is, and they are stored contiguously as long as we are within the bounds of what we've defined. So 5 short integer values. So you can see here, right there, how that would look actually in memory. So you can see here with this little graph, it's still on 513. So when we have asterisks and then in the parens numbers, I think it's numbers, yeah, +1. what we're saying is we've got a reference. That's what the asterisk here implies. It is not implying here a multiplication. This is the weirdest part of the chapter for some of you, because you see the asterisk and immediately you go, this has been multiplication in every programming language I have had. That's true, because pointers come up here in advanced programming. So this stuff floats to the top, essentially. So you've got the reference, and then in the parens numbers, so that's where numbers begins. Plus 1 is really the location of where numbers starts, plus 1, the next storage location over. So really you're looking at numbers sub 1 is what that portion of the that particular graph maps to. So it's a little bit different because we're working with the pointer. We're not actually working with the value that is stored there. We're working with the size of the location that is stored there. So that is one of the places where here in the beginning you can very, very easily get tripped up, and it's something to be aware of. As we continue on down through here, what I really wanted to point out is it's here in program 9-6. What page is this? 514. The way that we would use that concept here inside of a function is what we see right here. So really what we've got up here at the very top, line 7 through 9, I would say that is completely standard to what we have seen to date in the way that we have associated with an array, right? So then right here, we are working with just displaying the, we are working with interacting with the user in order to receive value. So we can see down here that we are going to enter 5, 10, 15, 20, 25. So those are going to be taken from our terminal into the array. Now here is where we've got the new wrinkle. We're going to display the values in the array using pointers as opposed to using the subscript, the element of the array itself. So what does that look like? So right here, this is the only real change. So we are still using a for loop here. We could have used an enhanced for loop, but one thing at a time, everybody. So for count equals 0, count less than size, count plus plus, all standard array operations here. We are saying that we are going to output the following values here. So this is where the big change in just using the array at a subscript, this is where we're seeing the change. Now, again, because we've got that asterisk outside of our parentheses, this is letting C++ know, hey, pay attention, pay attention. This is, in fact, a pointer. And what we're going to point to is what is inside, numbers plus count. So it is the numbers array plus count. So that count indicates how many elements in the array it is that we are moving forward. So number plus count on the first time through equals 0. So it's the 0th element in our array that we are outputting the value of. So the next time through, count equals 1. So it's our 0th element in that array plus 1. So go, the next value over and output that. And you can see what happens in the output window there below. It is, in fact, we can only go left to right, and that is a substantial problem for a left-handed person because I always want to go back this way. So we can see that the output here is going to work the exact same way as if we were going to use the subscript of the element. That's what we've been doing. So, array and then index inside of there. That's what you've been doing historically. And we're just making this small change here. Rather than say we have to pass more values over, why don't we just use the reference here and do a little bit of negotiation with C++ on where that array begins and how that array continues to, take up space, in memory, and that's the way that would go. Now, please do continue down through here to look at this second, it's program 9-7. What we're saying is you can start at the back of an array, so at the very end, and work your way backwards to the front. So that's what we're seeing here is instead of, plus, we're seeing the backwards of it. It's just another way to look at the same thing. So here, the small wrinkle of difference is we can use the size of the array to traverse through our array based on the size of its elements as opposed to the subscript of its elements. It's just, two sides of the same coin here.